Okay, test review number 12. So we'll start with number 1. Simplifying, we're going to take out the greatest common factor, right? The GCF. So GCF in this case is going to be, in the top, 9 and 6 are both divisible by 3. So I'm taking out a 3. Left behind is a 3x minus 2. And you always check yourself to try to redistribute just to make sure. 3 times 3 is 9. Times 2 is negative 6, so we're good there. All right, in the denominator, GCF is going to be 5. 5 is common to both 15 and 25. 3x plus 5. 5 times 3, 5 times 5. All right, and that's it. So remember, you cannot cancel when their term is being added or subtracted. So you cannot do that. So this is the final answer. Okay, number 2. Again, GCF in the numerator. 4 is common to both 4 and 4. So this is going to be 4 comes out, x minus 1. Right, because when you put it back in, 4x minus 4. All right, on the bottom, this is x squared minus 1. Here you have to realize that this is really a difference of squares. X squared minus 1 is exactly x minus 1, x plus 1. All right, it's a difference of squares. You just have to see that at this point. The thing that cancels here, what's in the numerator that's also in the denominator, x minus 1, x minus 1. So final answer is going to be 4 over x plus 1. You don't need parentheses. All right, number 3. Okay, here, remember, negative exponents are bad in a sense that you can make them positive, but move their location. So if it's a negative exponent in the numerator, you move it to the denominator, make it positive, and vice versa. Here, we want to apply the negative 2 to everything in the numerator first, right? Because parentheses exponents go first. So this is going to be 3 to the negative 1/2 power. X, power raised to a power you multiply. So negative times negative is a positive. 2 times 2 is 4. And then y to the negative 2. And this is all over. Again, x to the 4, y to the 2. Okay, we're going to move everything that has a negative exponent first. So the 3 is actually going to go into the denominator. So 3 to the negative 2 is actually 3 squared, and you move it down. So that goes away. The next negative exponent, y to the negative 2, that's going to move down, y positive 2, and now that's canceled. Right? You make the exponent positive, or you change it to positive, and you move it opposite of where it is. Okay. Let's start simplifying. So x4 on top, x4 on bottom, that goes away. So when everything cancels in the numerator, the only thing left is a 1, right? When everything cancels, it's just 1. And the denominator, we have 3 squared, which is 9. And then y squared times y squared, right? This is multiplying. You add the exponents. So y to the 4th. Okay. Number 4. Okay, we're at the slide and divide on top. So this is a quadratic. So we know how to solve quadratics by using the slide and divide method. So really, 6 times 15, right? 6 times 5, 30. Carry the 3. 6 times 1 is 6, plus 3 is 9. Okay, we need to come up with two numbers that multiply to make negative 90, but add up to 1. Two numbers that multiply to make negative 90 that add up to 1. What two numbers are close together? 9 and 10. And this would be a negative 9. Right? Negative 9 times 10 is negative 90. Negative 9 plus 10 is 1. All right, this means x minus 9, x plus 10. But this is the slide and divide method. So once we slide and we get our numbers, our factors, then we divide. And we reduce when possible as far as we can. So this is going to be x minus, divide by 3, 3 over 2. This is x plus 5 over 3. Okay, now in this method, once we have our fraction, these numbers go in front, right? After we simplify as much as we can, if there's a fraction left over, the denominator goes in front of the x term. So we have in the numerator 2x minus 3, 3x plus 5. And this is all over 3x plus 5. So cancel, right? Whatever's in the numerator is also in the denominator. We can cancel it out. So final answer, 2x minus 3. Okay. 5. It's already factored, so that's kind of nice. Whatever is in the numerator is also in the denominator. So here we have x minus 1 cancels with x minus 1. Final answer, x plus 2. Okay. Number 6. In the numerator, we have a difference of squares. So this is x minus 3, x plus 3. In the denominator, we have to figure out what two numbers multiply to make 6 that add up to 5. Two numbers, 6. So 2 and 3. 2 times 3 is 6. 2 plus 3 is also 5. So those are correct. So in the denominator, we have x plus 2, x plus 3. So everything's fully factored. We look to see, can we cancel anything? And yeah, we can. X plus 3, x plus 3. So final answer, x minus 3 in the top, x plus 2 in the bottom. Okay. Number 7. GCF, greatest common factor. What is common to both 4x squared plus 4x? Like number-wise, to 4, right? 4 is common. And then x's, variables, the most x's I can take out is I can take a single x out from each term. So then what's left behind? X plus 1. Right, because if you put it back in, this would be 4x squared plus 4x. That's exactly what we had in the numerator. Okay. Bottom, we need to figure out what two numbers multiply to make 3 that add up to 4. Only one combination, 3 and 1. So this means in the denominator, x plus 3, x plus 1. So everything's fully factored. We look to see, can we cancel anything? We can. X plus 1, x plus 1. So final answer, 4x, x plus 3. Nothing else can cancel. Okay. Number 8. So here, nothing's being added or subtracted. Everything's being multiplied. So technically everything is factored already. So can we simplify? Right, there's 5y's in the top, 2y's in the bottom. So what this is saying, right, is that I can cancel out 2 from the bottom and 2 from the top, right? And that leaves behind 3. So y cubed is left over. The same idea for the x's, right? There's 2 x's on top. There's 3 x's in bottom. So 2 cancels with 2 in the bottom. 2 in the top, 2 in the bottom. So we're left with 1x in the denominator. And then finally, 4, right? There's 1 4 in the numerator. And 4 times 3 is 12. And this would be our final answer. Just remember, if the variable is even, right, on top and bottom, if you can take it away from both the top and bottom, that's how you cancel it out. Okay. All right, we're going to use Schrady, the acronym that we use to figure out how to graph a rational function. So first step that we always do is try to simplify as much as possible. And here we see that we can simplify the denominator, because the denominator is a difference of squares, right? 16 is a perfect square. X squared minus a perfect square. X plus 4, x minus 4. So this would be the simplified version. Then we look to see, can anything cancel? Okay. Nothing cancels. So that means there's no holes. Right? If something were to cancel, then there would be a hole at that value. There's no hole, right? Nothing cancels. So then we go through our list. First, we set the top equal to 0, numerator. So x squared equals 0 if and only if x is 0. So at x being 0, we know that it crosses the x-axis at 0. Now, coincidentally, we just found the y-intercept. Right? This doesn't always happen, but right now, that is what's happening. Right? Y is equal to 0, because that's where the graph is going to cross, at y equals 0. So 2 birds, 1 stone. It's kind of nice. Vertical asymptote is when the bottom is equal to 0. So remember, this is where we say the inside lies, right? Because we just look at the denominator. Whatever value for x makes that factor 0, right? X is equal to negative 4. Right? If x is equal to negative 4, then this side is equal to 0, and the denominator is equal to 0, and that means undefined. What makes the other factor 0? Well, x equals positive 4. Right? That would make this side 0, and 0 times anything is 0. We'd have division by 0. And when 0 is in the bottom, again, undefined. So this means that there's a vertical asymptote at x equals 4 and x equals negative 4. So here's my vertical asymptotes. Okay. Depending on who taught this to you, the tangent together part, the way I teach it is that we look to see if there's any squared factors in the numerator and then in the bottom, in the denominator. So right now, is there a square factor in the numerator? Yes, there is, x squared. Now, so what this means, right? What this means is that at x equals 0, the graph is going to bounce. It's either going to bounce upward or it's going to bounce downward. At the moment, I don't know, but we'll figure that out here in a second. Is there a square factor in the denominator? No, there isn't. Right up here, there's a squared term, but that's not what we look for. We're looking for a squared factor, right? After we factor, is there a factor that is squared? And the answer is no, there's not. When that's the case, this means that at the asymptote, at each of those asymptotes, right, x plus 4, x minus 4, that the graph will go opposite. Now, is it like this? Or is it like this? Right, at the moment, we don't know. But we'll be able to figure that out here in a second, right? So this means that they're going to go opposite. Okay, in behavior, this is the horizontal asymptote, right? And we analyze that. We look at the degree of the leading terms. It's either going to be balanced or it's going to be bottom heavy. So here, x squared on top, x squared on bottom. So it's balanced, right? This is definitely balanced. And when it's balanced, we take the ratio, right, the fraction of the coefficients, the front numbers, the fraction of the front numbers, right, ratio of the coefficients. So it's understood that there's a 1 in front of x squared. So 1 over 1. Y is equal to 1 over 1, which in this case is just 1. So the horizontal asymptote is at y equals 1. There it is. Now, this is everything we need to figure out how this graph looks, because the graph has to go through the origin and it must go away from the horizontal asymptote. So more or less, it's going to look like this. And we're not really looking for precision, but we're looking for accuracy. So it just needs to go down. Because it goes down on this side of the asymptote, on the other side of the asymptote, it must go opposite, right? It must go up on both sides. So we go up and then towards infinity. On the right, again, it goes up and then towards infinity. And there it is. The domain and range. So domain and range. So the domain, there's a couple different ways to look at this. It's going to be, you could say all real numbers, right? The domain is all real numbers, but minus or take away, right? Take away the asymptotes. So how do I want to do this? X cannot equal 4 and negative 4. Right, the range is all real numbers, negative infinity to infinity, or not or, but also x cannot equal negative 4 and 4, right? Because we have asymptotes there. Right, the same with the range. The range is going to be all real numbers, but y cannot equal 1, right? Because there's an asymptote at 1. The graph will approach 1, but it'll never be 1. Okay, is there more graphing? Yeah, there is. Okay. So let's try it again, shall we? Okay. First thing I'm going to do is simplify this. We can simplify the bottom. All right, what two numbers multiply to make negative 12 that add up to negative 4? 6 and 2. So negative 6, positive 2. So this is going to be x plus 2 over x minus 6, x plus 2. All right. Everything is factored. Now we look to see, can we cancel anything? So yeah, we can. x plus 2 is going to cancel with x plus 2, leaving behind 1 over x minus 6, right? Because the x plus 2 is canceled. Next, holes. We just said that if something cancels, then there will be a hole. So there's definitely a hole at, and inside lies, right, at x equals -2, right? Because the denominator, whenever the denominator equals 0, right, inside lies, the value that makes the denominator 0, at the end of the day, it's an asymptote, right? It's always an asymptote, except when it cancels. It gets upgraded to a hole. So instead of an asymptote at -2, there's going to be a hole at -2. Okay. And there's really nowhere, like, I'm not going to draw an asymptote like this, right? Because that's just not the case. It's not an asymptote, but wherever the graph crosses this line, there will definitely be a hole there, which we'll cross that in a second. All right, let's set the numerator equal to 0. Well, the numerator is 1. There's no x values. So this means that there's no root. Right? There's no way that 1 can equal 0. So there's no roots. That means it does not cross the x-axis. Thinking ahead, that means there has to be some sort of horizontal asymptote at y equals 0, but we'll cross that bridge in a second. Okay, vertical asymptote is when the bottom is 0. The bottom is 0 when x is equal to +6. Right, if you plug in +6 for this x, it makes the bottom 0. The x plus 2, that's actually gone. Right, there's no x plus 2, right, because there's a hole. So vertical asymptote, there's only one, and it's at x plus 6. Okay. What else? Tangent together. So we look to see, are there any square factors in the numerator? No, there's not. It's just a 1. So no, there isn't. And really, I'll leave it alone. I'll say that's really if there's a square, right? But yeah, I'll leave that alone for right now. So there isn't a square factor in the numerator. Is there a square factor in the denominator? No, there isn't. So what this means is that at the asymptote, x equals 6, the graph are going to go opposite of each other at the ends, right? At the ends, it's either going to go up and down, or it's going to go up and down, right? We don't know what side it's going to be on yet, but we'll get to that here in a second. So now, in behavior, so we're looking at the degree in the numerator versus the degree in the denominator. Now we're always looking at the simplified version, right? There's more x's in the bottom, so this is going to be what we consider to be bottom heavy, right? There's more x's in the denominator than there is in the numerator. When it's bottom heavy, it's always y equals 0. Okay, so y equals 0. And then last but not least, the y-intercept. So we plug in, right, 0 for x. So when x is 0, when we plug that in, we get -1/6, right? Y is equal to -1/6. So when 1/6, that's in between 0 and 1. So -1/6, we can just call it right there. Okay, so now this is exactly everything I need to draw this graph. So I know that it has to pass through -1/6. So that means the graph is going to be towards the bottom, or on the bottom of the x-axis. And then it's got to go and turn towards the asymptote. Again, don't care about precision. I just need to be accurate, right? Accuracy is what counts. So now, a couple things. Because the graph is going down on the left of the asymptote to the right of the asymptote, it must be in the opposite direction. And then towards infinity. All right, and the last thing is that we said that there's a hole at x equals -2. So at x equals -2, right? You don't necessarily have to write this out every time, but I just want you to know that there is a hole. There is a hole. So when it comes to domain, right, the domain is everywhere the graph exists. So the graph exists everywhere in terms of x, except for two spots, the hole and the asymptote. So -2 and 6. So we said all row numbers, but x cannot equal -2, cannot equal 6. Right? It's almost kind of like set notation. That's not a J, that's a semicolon. So in terms of y, again, all row numbers, but y, in this case, cannot equal 0. So you exclude the asymptotes and the holes. Okay. Number 11. All right, simplify if needed. No need. Right. It's already as simple as it gets. Can anything cancel? Nope. Nothing cancels. No holes. So that's kind of a good thing. All right. We set the top equal to 0. X must be -2. So the graph is going to cross the x-axis at x equals -2. Must, right? When the top is equal to 0. All right, when the bottom is equal to 0, x minus 3, x has to be 3. All right, that's the only thing that'll make x minus 3 0. Right? You add 3 to both sides. So at x equals 3, there's a vertical asymptote. There we are. Okay. Is there a square factor in the top? No, there isn't. So that means nothing to me, right? I only care if it's yes. If it's yes, then something happens. But since it's no, then we just skip it. Is there a square factor in the bottom? Again, no. Now, to me, this means that the graphs are going to go on opposite sides of the asymptote, right? One side's going to go up and one side's going to go down. That's what the bottom means when it's no, right? When there's no square factors. Now, you may ask, well, what happens if it's yes and there is a square factor? Well, then they will converge on each other, like they'll come together, right? They'll either both go up or they'll both go down. If the answer was yes, right? If the answer is yes. But it's not yes, it's no. All right, in behavior, we need to look at the degree in the numerator versus the degree in the denominator. And here we see x to the 1, x to the 1. So they're equal. They're balanced. They are balanced. When they're balanced, we look at the degree, not the degree. We look at the ratio of the coefficients, right? The fraction of the numbers in front. 1 over 1. In this case, it's 1. It's not always going to be 1, right? It's not always going to be 1. It's whatever the ratio of the numbers in front are. And in this case, 1 over 1 is just 1. So there's an asymptote at y equals 1. There we have it. All right, last piece of information is that we need to let x equals 0 because we got to figure out where does this graph cross the y-axis. So the way I do this, look at the original problem, and you just let x equal 0. And y is going to be equal to 2 over -3. So -2/3. Negative 2/3 is going to be below the x-axis in between 0 and 1, right? 2/3 of the way. So somewhere right in there. Okay, this is all we need to figure out what the graph looks like, right? Because the graph has to pass through the x-axis and the y-axis. So this is one branch, or graph rather. Call it branches. And now we need another branch, right? We need to look at the opposite, right? Opposite. So if one branch went down one side of the vertical asymptote, the other side must go up in the opposite direction, right? That's what it means for opposite. And then out towards infinity. Okay. Domain and range. Looking at all real numbers, but x cannot equal 3. Y is going to be all real numbers, but y cannot equal 1. Right, remember, range is the y values, and domain is the x values. All right. Last one. I mean, feel free to like pause the video and see if you can answer and do the things that I'm saying. Okay. We simplify. So what two numbers, if possible, multiply to make negative 10 that add up to negative 3? So this is going to be 5 and 2 multiply to make 10, but one needs to be negative. And it's the big one because it needs to add up to negative 3. All right. So the simplified version form, x minus 5, x plus 2. Can anything cancel? No, it can't. No holes. Right? Nothing cancels. So then we start going through our process, right? Looking at the simplified version only. Is there any way to set the numerator equal to 0? Yeah, we can. X equals 0. So right away, we see that we have to cross the x-axis at x equals 0. Now, coincidentally, when it's the origin, we just found out the y-intercept is also y equals 0. Right? Write that in at the bottom. Now, that doesn't always happen, but when it's the origin, 2 birds, 1 stone, right? Okay. Vertical asymptote is when the bottom is equal to 0. And here, like, inside lies. Definitely inside lies. This is going to be x equals 5, right? Because that'll make this 0, and 0 times anything is 0. And then x equals negative 2. Again, that's going to make this 0, and 0 times anything is 0. So vertical asymptotes at negative 2 and positive 5. Okay. Tangent together. Is there a square term, or sorry, a square factor, a squared factor in the numerator? No, there isn't. Is there a square factor in the denominator? No, there isn't. Right now, you may say, well, hold up. There's a square here, but again, that's a squared term. That's not a squared factor. Right? We're looking for squared factors. That's key. Okay, in behavior, we need, what do we need? To look at the degree in the numerator versus the degree in the bottom. Like, where are there more x's? Are there more x's in top, or are there more x's in bottom? And you can see there's way more x's in the bottom. So we consider this to be bottom heavy. And when it's bottom heavy, it's always, you don't necessarily have to write always, but it's always y equals 0. It's kind of nice. Okay. So, again, there's, depending on who taught who's teaching this to you, it's all technique and understanding, right? Like, what do you understand? What did they explain to you? How did they explain it to you? So what I'm saying is that one thing that I've learned, um, right, when there's a square term in the top, like when you say yes, kind of like how we had a few examples ago, we know that the graph is going to bounce when it's yes, but it's not yes, right? It's no. So I know for a fact that this graph is going to cross through the x-axis, or the right, it has to cross through the x-intercept and the y-intercept. It's either the blue one or it's the red one. Now you may be saying, well, wait a minute, hold up, I thought it's not supposed to pass through the horizontal asymptote. Well, that's true. It's not going to pass through the horizontal asymptotes out towards the infinities, right? Because we said this is end behavior. What are the ends of the graph doing? The ends out towards infinity are approaching the asymptote, and they'll never cross at the ends. But when you're around the origin, and the x-intercept, the root is on the asymptote, then in this particular case, you are allowed to cross through. So is it the red one or is it the blue one? That's the question, right? Like, because it doesn't do both of these. It does one or the other. It's either the blue one or it's either the red one. The way we figure this out, we plug in a number. Say we plug in 1, right? When x equals 1, it's either going to be positive or it's going to be negative. So that's one of the reasons behind testing the point, right? Some people teach just test a point and then see where the graph is going to go, right? That's a way. That's a way. So here, if we test a point, let's test 1, right? We're going to get 1 over 1 minus 5 times 1 plus 2. So really what we're looking for is this positive or negative? Well, this is going to be 1 over 1 minus 5 is negative 4. So right away, I know that this is going to be negative, right? Because negative times a positive is a negative, so negative 12. So negative 112. So that means that it's going to be the red graph. The red graph. And negative 112, it's actually more curved, but that's actually fine. Okay, so now that I know that it's the red graph, and I know that since one side of the graph is going down, the other side has to go in the opposite direction. It's going to go up and out. Right, up and out. Opposite and out towards infinity. On the left-hand side, because this one's going up, the left graph needs to go opposite, so it's going to go down and then out towards infinity. And there you have it. That's what the graph looks like. So feel free to rewind it or go back and listen to my rationale on how to determine how the graph looks. Like, you might need to go over it a couple times, but I promise if you do the things I'm saying, look for what I'm looking for, you'll be able to graph it every time. All right, domain's easy. It's all real numbers. Take away all the asymptotes, vertical, that is. So x cannot be negative 2 or 5. As long as x is something else, the graph exists. Y is all real numbers, but y cannot be, that's right, 0. Okay, those are the graphs. All right, let's get to multiplication and division. My goodness. All right, the key here is going to be factor factor, and then cancel. Now, you can cancel top to bottom and diagonally, but you can never cancel side to side, right? If both things are in the top, you can't cancel. It's only top to bottom and top to diagonal, or diagonally top to bottom. Okay, and that's once it's factored, only when it's factored. So the only thing we can factor here is the bottom right. So two numbers that multiply to make 3 that add up to 4. So this is going to be 3 and 1, right? 3 times 3, or 3 times 1 is 3. 3 times 3 plus 1 is 4. So 3 times 1, 3 plus 1. And that satisfies what we're looking for. Okay. So now we factored everything, right? Everything's factored. Can't go anymore. Now we look to see, can we factor anything up, down, and diagonally? And we can, right? This x plus 3 doesn't necessarily have to be in parentheses, but you can cancel out x plus 3. So final answer, in the numerator, x plus, right? When something cancels in the numerator or in the denominator, right, it leaves behind a 1, and we don't care about ones. That's why we don't write anything, but just know that it's 1 times x plus 2 over 4 times x plus 1. So x plus 1. All right, that's the final answer. Let's do 14. So here we have division. So anytime we have division, we say keep, change, flip, right? Flip the second one. You always flip the one to the right. So what's going to happen is this is going to be x minus 5. This is 2x plus 6. So here, let's write it off to the side just so you can see it, right? So this is x minus 5, 2x plus 6, right? You just flip it. You flip the second one. So you keep the first one, change it to multiplication, and then flip the second. So there it is. It's multiplication. So now, can we factor the top left? Right? What two numbers multiply to make 12 that add up from negative 12 that add up to negative 1? I need to add up to a 1, so they need to be close to each other, like 3 and 4. So negative 4, 3. Negative 4, 3. So x minus 4, x plus 3. Okay, so here we can take out a GCF, right? Greatest common factor. 2 and 6 are both even numbers. I can take out a 2. This is x plus 3. Okay, put it all together. Can we cross something out diagonally or up and down? And we can, right? X plus 3, x plus 3. Also, x minus 4, x minus 4. So the only thing that's left, right? The only thing that's left is x minus 5 over 2. Right? That's really all that's left. Because once everything cancels out, it's just a 1 that's left behind. So our final answer, x minus 5 over 2. Okay, number 15. So here, it's multiplication, right? It's multiplying. So can't factor anything because there's no plus or no minus. Everything is basically factored. So now we start canceling things. So what can we cancel? There's an a in the denominator and 2 a's in top. So this is basically a, right? That's what a squared means. So we cancel. Now what I would have done, to be quite honest, cancel and then cancel, right? That 2 now becomes a 1. A lot of people don't like that. But there's two B's in the top, two B's in the bottom. Right? Just because this is being multiplied, this basically makes this one fraction. Right? Just so two B's in the top, two B's in the bottom. So final answer. 2A over C. 2A over C. I think the hard part here is noticing that this A is still there. Right? This A is still here. If not, just because the 2 canceled, the A didn't go away. That's kind of why, and when you notice, I just did the exponent and not the A. But you have to be able to see through all this scratch, right? See through all the slashes. Let's look at 16. Okay, here we can definitely factor some things out, right? It's multiplication, so we can definitely factor some things and then start trying to cancel. You can't cancel first, right? There's nothing that can cancel. So top left, 9 and 18, everything can be divisible by 9. So if I take out a 9, take out a 9, we're left with x plus 2. 9 times 9, or 9 times 1, then 9 times 2. All right, on the right, take out a 3, we're left with x minus 4. Right, GCF. And then on the bottom left, this is a quadratic. What two numbers multiply to make -8 that add up to -2? 2 and 4. One's negative. Which one? The big one, because -4 plus 2 is -2. So bottom left, we have x plus 2, x minus 4. So now everything is factored out, broken down, and we look to see, can we cancel some things out? First thing I see is 3 and 6. Right, 3 goes into 6 2 times. Right, you're dividing it out. And that's what it means to factor, I guess. Not factor, but simplify and reduce. All right, last, we have x minus 4, x minus 4. Also x plus 2, x plus 2. So final answer, what's left in the top? I'll highlight it. So we have a 9. Let's do yellow. So we have a 9. That's all that's in the top. And then in the denominator, the bottom, all that's left is a 2. And an x. Right, and an x. The x never got canceled. So final answer, 9 over 2x. So anytime there's a cancel, right? This is a 1, this is a 1, 1, 1, 1, 1. Technically that's 2. But yes, ones don't mean anything. So final answer. All right. 17. We're almost done. Okay, here we have to, it's an N, not an X. It's just GCF, right? GCF of the top, bottom, top left, bottom right, top right. So GCF, right, of each one. So 5 and 15, I could take out a 5. N plus 3. Bottom left, 4 and 8, I could take out a 4. N plus 2. Top right, 2 and 4, take out a 2. N plus 2. Bottom right, 3 and 9, I could take out a 3. N plus 3. Okay, now, this is fully factored. Can anything cancel? That's the question. Well, let's see. N plus 3, N plus 3, right? You can cancel diagonally. N plus 2, N plus 2. Top and bottom, diagonally. And then last, 2 and 4. 2 and 4. So 2 goes into 2 once, 2 goes into 4 twice. So final answer, remember this is being multiplied. So what's left? I'll highlight it. 5 2, and 3. So 5 on top over 2 times 3, 6. Okay. All right, number 18. Here, we're going to change division to multiplication and flip the second one. Right, flip the second one. Always flip and then cancel. Don't try to cancel first because that's not going to work. So 9x to the 4, 5x to the 6. Okay. We disregard this guy because that's going to mess us up. Because we flipped it, right? Okay. Start canceling. So there's 2 x's on top. Technically, hold on. So let's kind of like put these together here. This is, all right, let's do it like this. Let's do the numbers first. There's a 5 in the denominator, 15 in the numerator. So this is 15 divided by 5 is 3. Okay. There's a 9 in the numerator, 45 in the denominator. So 45 divided by 9 is 5. All right, 3 and 5 can't go any further. So let's kind of combine these ideas here, right? 3 is left, x squared, x4. So really, what do we have? We have 3 x to the 6, right? Because you add the exponents when you multiply. Over 5 x to the 9, right? Because 3 plus 6 is 9. So we have 6 in the top, 9 in the bottom. So these are going to go away. This is just going to be a 3 left over, right? Because you took away 6. So 3 over 5 x cubed. Final answer. Okay, is that it for that's it for this page. All right, we're almost done. Got 8 to go. Addition and subtraction. Okay, we're going addition and subtraction. So here we want common denominator. We want to add these together. So we just need a common denominator, right? It doesn't matter if it's the lowest or whatever, but we just need a common denominator. So what we want to do is multiply both sides by the other denominator, right? This is going to be x plus 2, right? Because that's the other denominator, top and bottom. And then x minus 7. Again, that's the other denominator, top and bottom. So when you combine, you're going to get x minus 7, x plus 2. Now, it's my recommendation that we don't combine them anymore. Leave them separate all the time, right? Don't FOIL out x minus 7 and x plus 2. Leave them separate. Because sometimes in the end, they might cancel again. You know, you never know. So then putting this back, not putting it back together, but distributing, we get 3x minus 3 times 7 is 21. Distribute the 4, we get 4x plus 4 times 2 is 8. So now we combine like terms in the numerator, right? Because right now the denominators match. X minus 7, x plus 2. So that means we can put it all together, one big fraction. So x minus 7, x plus 2. So combining like terms, 3x plus 4x makes 7x. Negative 21 plus 8. Negative 21 plus 8. So 20 minus 7 is going to be negative 13. And Final answer, because 7 and 13 can't be broken up anymore. Yep. Leave it at that. Okay. 20. Same idea, just slightly different. The only difference is that this right here is a quadratic and this is not. So if we figure out what factors this is, we can figure out what to multiply the other side by, right? Because what you don't want to do is multiply this side by x squared plus 6x plus 5. That is not what we want to do. That's going to make things exponentially worse. So let's factor the left-hand side. So, oops, not 5 and 5. What two numbers multiply to make 5 that add up to 6? 5 and 1, right? 5 times 1 is 5. 5 plus 1 is 6. So this is x plus 5, x plus 1. So notice on the right-hand side, we have x plus 5. On the left-hand side, we have x plus 5. So they both already have an x plus 5. So I don't need any more x plus 5. What I need is what this side doesn't have. This side doesn't have an x plus 1, top and bottom. So this is going to equal, again, x plus 5, x plus 1. That's what's on the denominator. So we're just going to make one big fraction. So we have 6x minus 7. And now we're going to distribute the 4. And it's a plus, right? So plus 4x plus 4 times 1 is 4. Combining the like terms, final answer, we're going to get 6x plus 4 is 10x. 7 minus 4. 7 take away 4 is negative 3. All over x plus 5, x plus 1. There it is. Final answer, because 10 and 3 can't go anymore. Okay. 21. All right, this one could be a bit tricky. So if you do what I said, right, multiply both sides by the other denominator, that would work. You know, it's respectable, following directions. However, if you notice that x plus 6 can be factored, this is going to be a GCF, right? 3 x plus 2. X plus 2. So then what this means is that here's x plus 2, here's x plus 2. I don't need any more x plus 2s. Bro, what I need is a 3 on this side, top and bottom, right? Top and bottom. 3 over 3, right? Because that was what this side has extra that the other denominator doesn't. So really, I don't even need to multiply anything on this side, right? Because it's already there. It's already there. So what we have, denominator-wise, 3 times x plus 2 all over. 3 times 7 is 21 minus 4. 21 minus 4, 17. 3 x plus 2. Final answer. Now, if you didn't notice that and you tried to multiply both sides, one side by x plus 6, 3x plus 6, and the other side by x plus 2, it gets a little complicated for sure. Just try to always notice the GCF. All right. 22. This says tricky. Okay. The reason it's tricky, couple different reasons. So at the end of the day, right? You multiply by the other denominator. You multiply by the other denominator, right? Just like in the last one. Like you easily could have done that. However, the reason this is tricky, well, it even says tricky, is because these two denominators almost look alike. Right? They almost look alike. We can make them look the same. The way we do this is if I factor out a negative. So if you take out a negative from one side, doesn't matter which side, I'm going to do this side because it's going to switch. Right? Because think about it. If you distribute it back, you're going to get negative x plus 5. And when you rearrange it, that's 5 minus x. Right? That's exactly what it is. So the trick, I don't know if it's a trick, but the way you do this, right? The way if you notice a binomial and all you want to do is switch the numbers or switch the terms, right? 5 and x need to switch places. So all you're going to do is factor out a negative, right? Factor out a negative. So now we notice x minus 5, x minus 5. All that one side is missing is a negative, right? And then I factored out the negative in the denominator. So this is going to be negative 1, negative 1. Right, I'm multiplying it by a negative 1. Which means this side doesn't get multiplied by anything. So the denominator is going to be negative x minus 5. Numerator is going to be x. Okay, so this is where it gets crazy because you have to distribute the negative. So when you distribute the negative, right, when I multiply by a negative, what happens? It switches, right? When you distribute, it literally switches the spot. So x minus 2. Now, this negative has to apply, right? We have to distribute this negative. So then that's going to switch them back, which is kind of crazy, right? It's gonna make this minus x plus 2, right? Minus x plus 2. And for us, x minus x is 0. So final answer is 2 over negative x minus 5. You might have to watch this one a couple times to catch all the little things that I'm saying, right? About the negatives. All right. We're almost done. What are we doing here? Okay. We're solving. So here, there's two ways of doing this. There's the butterfly method, which is nice when there's not that many terms, right? When there's not that many terms. This would be 7x is equal to 5x times x plus 2. Right, when there's not that many terms and it's just a single x on both sides, oh yeah, cross multiply and divide all day. So 7x is equal to 5x plus 10 minus 5x. We get 2x is equal to 10. Divide both sides by 2. X is equal to 5. So x is equal to 5. Technically, before you box it, you want to check to see if you plug them in. If you plug in your answer, will you get 0 in the bottom? Because if you do, well then that is not an answer. There's no solution. It's a extraneous solution is what they call it. So that's not the case here, right? 5 plus 2 is 7. And then when we plug in 5, we get 5. So this is fine. Okay. Cross multiply and divide. Again, single x's, I'm not worried about it. As long as there's a single x, you're good. And there's just two things, right? If there's multiple things, then we'll cross that bridge when we get there. So 2 times 2x plus 5 is equal to 6 times x plus 2, right? Cross multiply. Distribute 4x plus 10 is equal to distribute 6x plus 12. Move all the x's to one side. Minus 4x. So this is going to be 6 minus 4, 2x. Minus 12 minus 12. This is going to be negative 2. Divide both sides by 2. X is equal to negative 1. Again, we check to see negative 1 works. It doesn't make a 0. Okay. 25. All right, here we go. We have multiple things happening. 2 different ways you could do this. We could get a common denominator, or you get a common denominator and then solve for x. Or we combine the things that are alike first. Where to go? Okay. So there's different ways of handling this guy. Right. Me personally, there's one x. So let me just combine this over to the other side, right? I think that would be best. 5 over 2. Cancel. So 3 over x is equal to what? 3 minus 5 halves. So if I get a common denominator, this is really 6 over 2. Right, 6 over 2 is 3. So this is 6 minus 5, which is 1/2. And look, this is nice, right? This is nice. Cross multiply, 3 times 2 is 6, x. Right, so in this particular case, combining the number over, that really helped out. I'm getting a common denominator. Okay. Okay, number 26. So here, this one's kind of a messy one also. So what I want to do is I want to get a common denominator first. Try to combine some of this stuff. Yeah, so let's see if we can do that first. So this is going to be, well, let's see what happens. So this is going to be x squared minus 1, x squared minus 1. So we get 3x, x plus 1 is equal to x squared minus 1 on the bottom. On the top, we have 12 plus distribute, right, the 2, 2x squared minus 2. Okay, combining, we get 2x squared plus 10 over x squared minus 1. All right. So what we're looking at here, is this side and this side. Okay. This is a difference of squares. X minus 1, x plus 1, right? You got to be able to see that. Because we already have, we have x plus 1 and x plus 1. So what we don't have is the x minus 1. X minus 1, x minus 1. Okay. The bottom is going to be x minus 1, x plus 1. The top, we distribute. This is going to be 3x squared minus 3x. On the right, we're going to have 2x squared plus 10 over x minus 1, x plus 1. Okay. Now, here's the little secret. They're equal to each other. The denominators right now are the same, right? Across the board, x minus 1, x plus 1, x minus 1, x plus 1. So really, what that means is if the denominators are equal, then that means the numerators must be equal, right? If one fraction equals another fraction and the bottoms are equal, well, then the tops must be equal. So what I'm saying is we could just disregard the bottoms, right? Like it's irrelevant. And the problem is now just the numerators. 3x squared minus 3x is equal to 2x squared plus 10. So I'm going to move everything to one side. So this is going to be, so I'm going to rewrite it over here. This is 3x squared minus 3x is equal to 2x squared plus 10. Right, this is a lot easier problem because when you minus 2x squared, we get x squared minus 3x. I'm going to minus 10 from both sides, and this equals 0. So now this is just a quadratic, right? What two numbers multiply to make negative 10 that add up to negative 3? Well, 5 and 2. One has to be negative. It's the 5. So really, we have x minus 5. Oops, I don't know why I put 15. And then x plus 2. Oh, you can't see it. And this has to equal 0, right? This is equal to 0. So then we say inside lies. So then this is going to be x is equal to positive 5 and x is equal to negative 2. And we check to see if we plug those in, will we get 0? And no, we don't. So those are my solutions. Okay. Last one. So utilizing the fact that the denominators, like we just brought it up about the denominators all matching 2, 2, 2. We can disregard the denominators, right? When they all match, we don't care anymore, even if there's multiple ones. So this means that x minus 1 plus x plus 1, this needs to equal 3. So then combining like terms, x plus x is 2x, minus 1 plus 1, that goes away. And this is equal to 3. Divide both sides by 2, and x is equal to 3/2. So it's kind of nice when all the denominators match up You can just cancel them out, right? That's basically what this is. So good luck. Catch you guys in the next video.